Right, students, well, I thought I had all YouTube videos for the different quizzes, but I cannot find 703, and it looks like I used just the Screencastify link instead of uploading it to YouTube and then have deleted it. So now this is on YouTube. 703 for Algebra 2, Semester A, right triangle trigonometry. Okay, that's pretty good. That's always like the angle we want to see. And remember, it's okay if you're in the red or the yellow. You can always reach out to me for those questions and earn some points back. Try a retake, use this help video, and try a retake. But no matter what, keep thinking and trying. It's never fun to get answers wrong, but I get them wrong all the time, and I've just been okay with it. And know that you can earn those points back. Just reach out, talk to me. And yeah, if you don't know, you don't know. But as long as you're trying the thinking, that's all I can ever ask of you. Keep thinking. I'll try my best to make it make sense. If it doesn't make sense, we'll try again and try again and try again and try again. Okay, let me shrink this down. All right, variation 1. Well, actually, we're going to do all variations of question 1. So this is a great video to continue to watch. Sign C. So a couple of things really quickly. We have a chant. So ka to wa. If you watched the mini lesson, if you came to class or whatnot, I think of Finding Nemo. So ka to wa. So ka to wa. It helps me kind of remember the ratios. Another great question from class was, what is the sine, cosine, and tangent? So I've watched a couple of videos on my lunch break, and I read a couple of articles, and it really is just the ratio relationship of a right triangle and its angle. Do some more research to see if it makes sense to you. It has to do with like a circle and a curve and the angle as we take a look at the different lengths. And their ratio relationship, the angle, that the cosine or sine of that angle is the ratio. Anyway, the words are sine, which I think either meant like a curve, cosine, which is the complement of sine, cosine, and tangent. And then tangent means what we use this word, like to go off on a tangent, or mathematically, or the tangent to something is like when we're just touching it. Okay. Anyway, those are the main words. So for the mini lesson, those are the main trigonometric functions. And what they do is they relate the angle measure to the ratio of certain side lengths. So for example, they're asking for the sine of angle C. And remember, it's abbreviated SIN. That's sine. Cosine is COS, cosine, and tangent is tan, TAN. Those are the abbreviations when we use them as trig functions. So over here is angle C. Okay, right? It's labeled with that letter, angle C. That's this angle. So ka toa, so SOH, ka CAH, toa TOA. It's a mnemonic device to help us remember the ratio relationships. What it says is that the sine of your angle, so in this case, we're going to use angle C, is going to be equal to the length of the opposite, so across from the angle, over the length of the hypotenuse. And again, the hypotenuse is always across from the right angle or always the longest side of a right triangle, What we're talking about only applies to right triangles for now. There are different methods for different kinds of triangles, but for right now, they're right triangles. So they have to have a 90-degree angle signified by this box. Okay. So across from that is our hypotenuse. So what does that tell us? So that tells us that the hypotenuse is 17. That's what we're going to put on the bottom. The hypotenuse, the length of the hypotenuse will be the denominator for SO and ka, for sine angles and cosine angles. Now, the A or the O depends on what angle you're talking about and which one, are sine or cosine. So for sine, it's always going to be the opposite. So in that case, this is 8. If we were to draw this, angle C right here. Across from angle C, or directly opposite, is going to be the other side length. In that case, this is 8. Obviously, this is not to scale. It was just kind of to make a point. If you find your angle, the opposite side. Here's your angle, the opposite side. Here's your angle, adjacent. adjacent or hypotenuse, right? They make up the angle. I don't know. Think about it. That's kind of the hard part when it comes to triangle trigonometry, which has to do with triangles, but it'll make sense. So again, that'll be 8 over 17. Okay. Same triangle, just a different question. Cosine of C. So just like before, we have cosine. So the cosine of C, cosine of C will be equal to A over H. Okay. Well, the hypotenuse is still the same. Here's our right angle. Across from the right angle, 17. Cosine of angle C, here's angle C, but now we need adjacent. Well, look how this 15 is the adjacent side, right? It makes up that angle. So it's going to be 15 over 17. So you have to look at what angle are they talking about? What are the side lengths? And you kind of piece it together using those ratio relationships to figure it out. Okay. Tangent of angle A. So the tangent of angle A is now we've switched angles and we're asking for this angle down here. We're asking for the tangent, TOA. So the tangent of angle A, TOA, is equal to the opposite over adjacent. Opposite, 15. Adjacent. Now, how come the adjacent is 8 and not 17? Opposite and adjacent will always refer to the legs of a right triangle, so not the hypotenuse. The legs of a right triangle refer to the O or the A, and the H in the SOHCAHTOA or the hypotenuse will always be the hypotenuse. So tangent won't use the hypotenuse in its ratio relationships, but cosine and sine will. Okay? All right, so 15 over 8. Again, we just found the angle. We used our mnemonic device to remember that this trigonometric function is equal, of that angle will be equal to the ratio of the opposite over the adjacent sides. So the opposite length is 15. The adjacent is going to be the 8, not the 17, because that refers to the hypotenuse. Yes, it is technically adjacent to angle A. It's one of the angles that make up the angle. It's one of the sides that make up the angle, but it's not how we're identifying the pieces of this puzzle. Okay. Good questions in class, good questions in one-on-ones. Thank you for your thinking. If you're asking questions, that means you're thinking about it. So good job. Question 2, which angle has a tangent value of 7 over 24? Okay, so a couple of things here. They're asking for the tangent. Obviously, okay, you know it's angle A, but let's talk about why. So the tangent, question mark, we don't know. Let's pretend like we don't know it's angle A. So they're asking us which one has the tangent of 7 over 24. Well, first of all, I need to remember TOA. That's equal, the tangent is equal to the opposite over the adjacent. So not the hypotenuse. Well, here's 24. So just by inspection, can we say that from B to C is the length of 7? Is that okay with you? Does that make sense? Given this ratio relationship. Okay, well now, if you're okay with that, which I'm okay with it, if B to C is 7, if this length is 7, that is the opposite. It's on the top, right? The top of our ratio. So that side length is opposite angle A. 7 over 24, and then here's the adjacent side. Remember, we don't use it for the hypotenuse. This is always going to be H, the hypotenuse, because it's across from the right angle, and it's the longest side. 7 is shorter than, and 24 is shorter than 25. Okay, so again, let's take a look at the next variation. I'll try to there we go. Okay, cosine of 7 over 25. So let me scroll over here so we don't see the answer. They're asking for a cosine. Which angle has a cosine? So question mark. We could use theta as a placeholder. That's a Greek letter theta. It often refers to angle measures. So has a ratio of 7 over 25. So first I just write it up like this. So ka toa, and remember that cosine is ka, so a over h. And now I just have to check. Well, h is the hypotenuse. Well, that's fine. That's 25. But if 7, so we've already talked about length b to c, is the adjacent, it's not going to be the right angle. It's not going to be the right angle because, look, it has to be the adjacent over the hypotenuse. So here's the hypotenuse. Here's 7. So we take this angle with the hypotenuse, and it forms angle C. So the cosine of angle C is the adjacent 7 over the hypotenuse. I had some great questions as to why it's not B, the right angle. How come it couldn't be cosine B? Because cosine B, look at those. Those are both, I don't know. So I'll let you think about that. Let me know what your thoughts are. How come it's not the cosine B? Because 7 is an adjacent over 25, but so is 24. So is the cosine of B the same as 24 over 25 and 7 over 25? I don't know. Anyway, let you think about that. For now, don't worry about the right angle. You're going to be referring to the other angles when you're first learning this math, okay? And you can think about it, but I just, for purposes of problem solving, the non-right angles are typically what the trigonometric functions apply to. Typically. Oh, no! All right, let me pause it. Hold on. All right. The sine value of 24 over 25. That's what they're going to ask us for this diagram. Sine is SOHCAHTOA, so we need the sine of some angle. We're going to call it theta, so we get used to that symbol. Opposite over hypotenuse. That's the typical ratio relationship. SOHCAHTOA, opposite over hypotenuse. So they're saying the opposite side is 24. Boom. So 24, right? They gave us in our problem sine value of this. And then the hypotenuse is 25. Okay, great. So this is the key one that's going to help us. This side measure length is opposite angle E. So sine of E is equal to 24 over 25. Okay, good work. That was every variation on question 2. So everybody should be earning at least 40% by using these videos, right? You get those 2 correct, provided you pay attention to the key details, make sure you look at your question, select your right answer. All of that matters, and all of that's great practice. Now we're just going to pick one. All right, we're going to go with this one. You're going to have a different, and you guys working with me helped me. Might have a different trigonometric ratio that you need to use depending on what your question is asking. So the setup is going to be the same. Then you're going to try to pick which one makes the most sense to use to solve. Okay, let's go through it. You're given a triangle ABC, and it's a right triangle. Okay, so let's just draw that. Whoosh, whoosh, whoosh. All right, I did the best I could. Here's the right angle to the best of my ability. The right angle C, that matters, so label that C immediately. So you understand, that's, my triangle. Don't worry, it's not to scale. We're not using the scale. We're using the labels to make sure we have the right relationships in our diagram. A, C, okay, so now I just need to label the rest of the points. I often start with A, B, C. Depending on what they give me, this is usually the setup of a right triangle, usually. But sometimes it's different. It could be angle B, it could be angle A. It doesn't really matter as long as you're clear which parts you're using. A to C is 15 centimeters. Okay, this is important because now we're getting into making sure all the lengths match up. A to C is 15 centimeters. I'm just going to write 15 for now, but notice the units are centimeters. Now they're telling us that M of angle A, so that notation, the little cursive M, tells you the measure of angle A is 40 degrees. So this is angle A, and that measure is 40 degrees. Okay, now they're asking what is B to C. So they want us to find B to C, this length down here. I'm going to write it as an X because we're used to using X as a placeholder for like an unknown that we're solving for. All right, we're ready to go. The next step that you really want to do is just kind of list out your ratios with the given angle. You could, of course, find other angles if you want, absolutely. I think especially when it comes to math and geometry and use what's given if you can. If you need to find more information, then you can use other strategies because there's different ways to solve this. But for right now, I would recommend using whatever angle they give you. And so they give you angle A. So let's set up SOHCAHTOA. So the sine of 40 degrees, I put the actual value in there. Yes, put the real value in there because that's a number. You can go put that in your calculator and it's going to spit out some sort of decimal, a ratio of the opposite over hypotenuse. Isn't that cool? All right, so the sine of angle A is going to be x over a to b, which we're just going to call h. Okay, that doesn't really help us because they didn't give us the length of the hypotenuse. So, all right, no worries. Let's go to the next one. Cosine of 40 degrees is going to be equal to adjacent. Okay, there we go. 15, we know that one. Eek, over hypotenuse. Okay, so we don't know h, so that doesn't help us either. All right, we've got one more, and if that doesn't help us, then this is unsolvable. Just kidding, it's not unsolvable. The tangent of 40, TOA, opposite, so x, over adjacent, 15. Winner, winner, winner. We have all pieces of our puzzle that we need to solve for that length, that blue side length, B to C, C to B, that x. Okay, so this is a great strategy if you just don't even know where to start or you're having a hard time setting up the ratio relationships. Just write them all out carefully. And if you have a repeat, then you did something wrong. If you have them in the wrong place, just kind of check your numbers when you're done, and then you'll be able to, you'll be able to solve. So notice we didn't have h, so sine doesn't help us. We didn't have h, so cosine didn't help us. But tangent will help us solve for this side length because the tangent of angle 40 is equal to the opposite length over the adjacent length, so x over 15. Now we go to our standard problem solving skills, which means we need to solve for x. So you're going to multiply both sides by 15. Boop, boop. Okay. That cancels this 15 because x is being divided by 15 right there. So to undo division, the inverse operation is multiplication. What you do to one side, you've got to do to the other side, okay? So I'm trying to repeat these strategies that you see in math quite often. Repetition, look for those patterns, and solving for unknown values. So now we know it. We're ready to go. It's funny they don't give you a calculator because you absolutely need a calculator for this, unless there was like a table of values. But let's talk about it. Get out of here. You can go to function if you want and do tangent of 40 degrees. You need to make sure this is toggled to degree. Radian, degree. Radian, degree. Wow, look at that. That's a huge difference. Look at the numbers. So make sure this says degree, not clicked over to here. Like that you might think, oh, degree is under here, so it's selected on it. No, you need it to say degree. So now there you go. Okay, that's not our answer. That is actually going to be the ratio of the opposite over adjacent. The TOA, tangent of 40 is equal to the ratio of the opposite side length over the adjacent side length. And it gives you that less than 1 decimal. Cool. But we had to solve for x. We want to know what that length is. So we're actually going to multiply both sides by 15. So we'll have 15 times the tangent, and you can just type it, of 40. And you don't need to put the degree symbol. Okay, so it's 12.6. Be sure to round to the tenths place. It says so on your question. Attention to detail. If you get it marked wrong because you didn't just let me know. I can add those points back in. So the length of that side is going to be rounded to the nearest tenth, 12.6 centimeters. Okay, but now let's just watch this. Since I have you here, see the tangent of 40? Well, TOA, it should be opposite, so 12.6 over adjacent, which is 15. Look how close that is to this one, to the tangent of 40. Look at that. So it's estimated, right? Because we rounded that length. But that is what you're doing with these functions. They just found that there was a consistent ratio relationship. And so they wrote them as a function saying, hey, the tangent of this angle will always be equal to the opposite over adjacent. The sine of this angle will always be equal to the opposite over hypotenuse. And the cosine of this angle will be equal to the adjacent over hypotenuse. So they just listed these functions to represent that outcome for every right triangle of those side lengths and that relationship. And that helps you solve a lot of cool things. But anyway, hopefully that answers some questions. Again, your question might ask you to use the sine or the cosine. They might give you A to B and ask you to solve for A to C, or they might, whatever they give you, be sure to label your question carefully, set up your trigonometric functions, and go from there and solve for the unknown. There's more than one way to solve this. So have fun with it. Try your best. Triangle math is fun. All right, let's keep going. Fun is hard, but that's okay. Here we go. So we're going to do a wooden board leaning against the base of a house 10 feet away from the base, and it forms a 35-degree angle with the ground. What is the length of your wooden board? Okay, here we go. We have this beautiful wood grain board. I'm going to draw the wood grain. There's like a knot in the wood. Stunning. Absolutely stunning. See, I love wood grain. Okay, there's probably a knot right there. Happy little trees, right? We're just drawing. It doesn't really matter. Okay, you absolutely don't need to do that. I'm being silly. But here's our wooden board. It is leaning against a house, which we're just going to draw as a line. And it is 10 feet away on the ground, 10 feet from the base of the house. Often houses meet the ground at a 90-degree angle. Very close enough for what we're doing here. Okay, your house should be straight up and down. It shouldn't be at a lean. If it is at a lean, call your landlord, call a construction person, evaluator to have that checked out. But anyway, so close enough, our right angle with the ground, so that it says it's 10 feet from the base of the house. It's leaning against the house, and it forms a 35-degree angle with the ground. So here it is. They're saying that's 35 degrees. With the ground is that key phrase to help you draw this situation. Have fun with it. I do recommend always drawing a picture when it comes to triangle math and labeling it to the best of your ability. Look for those clues, check it to make sure it makes sense. And it's a great life skill anyway, because sometimes a problem just needs a diagram or a picture to help us solve. Now what? What's the length of the wooden board? Okay, question. The length of the wooden board. That's a valid skill. Like they will do this in different situations. Maybe it doesn't make sense to go get that piece of wood and measure it. Maybe it's really tall, maybe it's really small, and this is just easier to do for whatever situation they're in. We know all this information. So what can we do to figure out that length? Well, we're given an angle and we're given a length. So we want to think about our trigonometric ratios. I'm instantly thinking cosine. Why? Well, what is this wooden board? Is it the hypotenuse, opposite, adjacent? And hopefully you see this is the right angle. It's across from the right angle. That's the hypotenuse. So I need either so, because of the hypotenuse, or ka, because of the hypotenuse. So then to think between these two, and you can set up the ratios. I'm just like we did in the last problem. Just set them all up, see what you have with the given angle and what you need, what you're solving for. We're going to again call this x, which is question mark, or you could call it h if you wanted. Up to you. They're all like the same thing. We don't know the length. We're going to solve for that. I'm given this 10 feet. Well, that's adjacent. That is the ground, and it is adjacent to this angle 35. So I want to solve for h, and I have the adjacent length to the angle given, so I think cosine. But remember, you can always set them all up and see which one makes sense. So cosine of 35 degrees is going to, and you don't need that symbol in your calculator as long as it's switched to degrees or radians, which we'll talk about soon. Adjacent, which is 10, over hypotenuse, which we're solving for. X, it's unknown. Now you're going to do your normal problem solving skills. X is now on the denominator. It's the bottom of the fraction, and that isn't good for us when it comes to solving. So we're just going to multiply both sides by X to get it out of there, right? So now over here we have X times cosine 35 degrees is equal to 10. Then finally, to get X alone, you're going to divide both sides by cosine of 35 degrees, right? So 10 divided by the cosine of 35 degrees. And you could write this out in like a separate step. I have this little rectangle of space, and I want to write large enough so you guys can see it. Okay, this cancels. So now we're equal to X is equal to 10 divided by cosine of 35, and that will give us the length of our wooden board. So we have 10 divided by the cosine of 35. And then again, rounded. Okay, that's pretty easy for us. To the nearest tenth, 12.2 feet. And listen, feet. Yes, feet. It's in terms of feet. So 12.2 feet. There you have it. Question 4. Yours is going to have a different distance from the base of the house and a different angle. But I think the setup for all variations is very similar. So you'll have something where you most likely, I think, use the cosine of the angle, but you're going to have that as the denominator to solve for the hypotenuse. Because when you set that up, the hypotenuse is equal to the adjacent divided by the angle, the cosine of the angle. Okay. All right, question 5, the last fun one. Do we want to do Melissa, Jacob, or Mia? Okay, so we got Mia on a radio tower. We've got Jacob from a building, and we got a tree. Let's do Melissa so we can draw the tree. How tall is the tree? Round the final answer to the nearest tenth. Okay, cool. So let us draw our tree. It's a beautiful tree. Oh, I should even get like colors on this. No, come here. So do like a nice dark green. Oh, it's beautiful. So Melissa has this beautiful tree. Let's go back to those brown colors. You can fast forward till we get to the point. Where is it? Where's like the brownish colors? Maybe this, like a dark, that'll work. It's like a redwood tree. Redwood was the mascot of my high school, right? That little root system. Okay, I'm happy with it. Some branches. All right, there we go. We have our tree. And Melissa, where are you, Melissa? I'm gonna put you in pink. So Melissa is standing about 40 feet. Hi, guys. Well, all right. She's dancing. 40 feet away from the tree. So this is 40 feet. The angle of elevation from where she is standing on the ground, so on the ground, to the top of the tree, that angle of elevation, so we elevate up, is 50 degrees. Okay, so that's the angle of elevation. How tall is the tree? Oh, okay, so we want to know how tall is the tree, X. We'll give Melissa some hair. Same thing. We have an angle measure. We have a side length. We're going to set up our trigonometric ratios and figure out which one makes sense to use. So notice they're asking for over here, and I would assume that this tree, there may not be a perfect point on the tree where it makes like a perfect right angle. That's true. Like you see the roots, they're going to be messy. But the concept from the straight up and down from the top straight down to the bottom, right, the height of the tree, that would form a right angle. So that would give you a good estimation about how tall the tree is, right? Straight up and down, when it hits the ground, that forms a right angle. So now we can estimate the height of a tree. This will work. If you have any of those type of surveyor tools or any way to measure your angle and know how far you're going to look to the top of something, you can use this to discover the height of items. How far away from you are the base? How far are you from the base? What is your angle looking to the top? And boom, you can solve for the height of many, many things. Okay. All right. I think tangent, but let's set up all of the ratios so you can see how. This is the hypotenuse, right? Because over here is our right angle. So this is our H. So I'm going to use the angle they give us, which is 50 degrees, and I'll write sine of 50 degrees is equal to the opposite. Cool, that's X. Nice. Over H. Okay, we don't know H. Okay, moving on. Cosine of 50 degrees is equal to the adjacent. Cool, we know the adjacent, 40 over the hypotenuse, but we don't know H. Tangent of 50 degrees is equal to the opposite, X, over the adjacent, 40. Nice. All right, we're one step away. All we're going to do is multiply both sides by 40, and that will give us the answer, the height of our tree. We'll go over here to our scientific calculator. Because it's X over 40, it's the opposite over the adjacent. We multiply both sides by 40 to get X alone. So we'll have 40 times tangent of 50 degrees. I forgot the angle measure. There you go. It should be about 47 and 7/10 feet high. It's a nice tall tree. That's lovely. It's feet because of the angle measure or the distance measured in feet. So it'll stay the same if you are using degrees and your distance is measured in meters or feet. Whatever units of measure you use will be the outcome. The final answer will be in those units. Okay, cool. Goodbye to our pretty tree. 47 and 7/10 rounded from our trigonometric functions. All right, hopefully this helped. Sorry for the silliness, but we talked about some really great ideas. Drawing a picture is important. Have fun with it. Make those mistakes. It's okay to make mistakes. Your labels are going to be wrong. Your answers are going to be wrong. That's okay. If you want the points, just ask me for the points. I'll give you the points back. But do the thinking. Try the thinking. Make those mistakes. And have some fun with these triangles and these real situations that comes into that has useful math later on in life, trigonometry, triangulation, and using these properties of shapes around you is pretty cool. Okay, who knows what you might come up with on what to use this type of math for.